going to put it all together. Now we're moving on. All right, so our first lesson, we were able to go from moles to mass and mass to moles. And then our last lesson, we were able to go from moles to particles and particles to moles. Now we are going to put it all together. Now we are going to be able to go from mass to mole to particles, or particles to moles to mass. All right, so how does this work? How do you calculate particles to mass? So the following conversion factors still apply. 1 mole equals 6.02 times 10 to the 23rd of whatever, particles, atoms, molecules, cupcakes, cookies, doesn't matter. But 1 mole also equals the molar mass of the substance. And remember, we get this from our periodic table. Now, both conversion factors are needed for these type of problems. So this equals a 2 ratio or 2-dimension problem. So first thing you are always going to want to do is you are always going to want to calculate the molar mass and make sure that you find the formula if needed first. Okay, now all of these problems, the formula is given to us, so we don't have to spend time on that. All right, but we do need to find the molar mass of all of these. So let's find the molar mass of K3N. So Kn, K is, the molar mass of K is 39.10, and the molar mass of nitrogen is 14.01. Now, since K is this, and we have 3 of them, we have to multiply this by 3, so we get 117.3. So mass of 117.3 plus 14.01 equals a mass of 131.31 grams. So this is our molar mass of K3N. All right, so we need to be able to go from molecules is what we're starting with. So we're going molecules. Next in our map is moles. And then from moles to mass. So when you make your map, your dimensions are going to match this process. So let's figure out what's our given. Our given is 3 times 10 to the 23rd molecule. So that's what we're going to start with here. 3 times 10 to the 23rd. And molecules I'm going to abbreviate as MCS. And I'm going to place it over 1. Okay, now before we do any numbers, molecules is my starting point. Next in my map is mole. So I'm going to put mole here. And then next in my map that needs to match on the top is mass, but remember the unit we're going to use for mass is grams. And I almost wrote mass. That's okay. Is grams. Now, before we do any numbers, if I have molecules here and I want to cancel it, where is it going to go? On the bottom here. And if I have moles on the top here and I know I need to cancel it, where is it going to go? It's going to go down here. So basically what this is this is a culmination of what you've been learning the last 2 days. We learned this last lesson. We learned this the first lesson. So what's the relationship between moles and molecules? Well, if you look here, 1 mole equals 6.02 times 10 to the 23rd particles, molecules, atoms, whatever. So the numbers are still the same. 1 always goes next to mole, and 6.02 times 10 to the 23rd is going to go next to molecule. Over here, we still agree that 1 always goes next to mole, and mass, since this is mass in grams, we're going to use our molar mass here, which is 131.31. Okay, so now molecules is canceled, moles is canceled, we're left with grams. Now we have to solve for the mass. So if we solve for the mass in our calculator, we need to multiply 3 times 10 to the 23rd times 131.31 divided by 6.02 times 10 to the 23rd. Now watch how I do this in my calculator. Must use parentheses. 3 times 10 to the 23rd times 131.31. I'm going to hit equals. Then I'm going to divide this answer divided by, you must use parentheses around any numbers with an exponent, divided by this number right here, 6.02 times 10 to the 23rd. And the answer that I get is 65.44 grams. That's my answer. All right, I'm going to round to the nearest hundredth. Okay, that's how we go from molecules to mass. Now we're going to do the opposite. Now we're going to go from mass to molecules. But first, we need to find the molar mass of Li2SO3. So Li is 6.94, and we have 2 of them. So that is 13.88. S, we have 1 of them, which is 32.06. and O, which is 16, and we have 3 of them, that's 48. So 13.88 times, or plus 32.06 plus 48 equals, so if we add all 3 of these numbers up, gives us 93.94 grams. This is our molar mass. I'm just going to do mm for molar mass. All right, so let's start with our given. Our given is 45.6 grams. 45.6 grams. Put it over 1. Okay, now I'm going to go from mass, so let's follow our map. We're going to go from mass to moles to particles. So that needs to match our dimensions on the top. Mass to moles to particles. Molecules, particles, whatever. It doesn't matter what unit you use here. Okay, so if I have grams here and I know I need to get rid of it, it's going on the bottom. And if I have moles here and I know I need to get rid of it, it's going on the bottom here. Now, what number always goes with mole? A 1. What number is going to go with grams? This is molar mass. Molar mass, molar mass. Here's our molar mass, which is 93.94. And then over here, we have moles and particles. 1 always goes with mole, and 6.02 times 10 to the 23rd always goes with particles, molecules, atoms, whatever. All right, these units cancel. These units cancel. We're left with particles or molecules, which is what the question is trying to find. Let's do the math. So we have 45.6 times 6.02 times 10 to the 23rd. Okay, this is what I get. Now I have to divide this number divided by 93.94. So I get 2.92 times 10 to the 23rd particles or molecules. That's my answer. All right, so last one. This one's a little easier because it's not a compound, it's just zinc. So molar mass for zinc is 65.38 grams. All right, and we want to know the mass of zinc in 7 times 10 to the 23rd molecules. So 7 times 10 to the 23rd molecules. Place that over 1. Okay, so we are going to be going from molecules to moles to mass. So our roadmap needs to go from molecules to moles to mass. So here's molecules, here's moles, here's mass. And in order to get things to cancel, molecules must go on the bottom here. And in order to get moles to cancel, must go on the bottom here. We put ones next to moles, and then molecules is always going to be associated with 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. And grams is molar mass, molar mass. And the molar mass we calculate, or didn't even have to calculate, we looked up, was 65.38. All right, let's do the math. Make sure you use parentheses around these two numbers. So we have 7 times 10 to the 23rd times 65.38. Okay, we get 4.576 6 times 10 to the 25th. Now we need to divide that number, divide the answer by, use parentheses, 6.02 times 10 to the 23rd. And we get a number like 76.02. 76.02 grams. That is our answer. All right, so something you should make sure of is whenever you are calculating mass, your number should be not an exponent. If it's an exponent, you did not use parentheses. Particles should always be 10 to the 21st to 10 to the 26th. You're never going to have a number that's 10 to the 48th. If you have a number that's 10 to the 48th, you did not use parentheses correctly. Okay, so the nice thing about our worksheets is they have all the answers on them in an answer bank, and I have also given you the answers in specific problems on Google Classroom. So you can always go and check. Make sure you check your exponents because, like I just said, your exponents should be times 10 to the 20s, somewhere in the 20s, not the 40s. All right, have a great day, everybody.